Canopy intelligence solves the core problem of the mid-time bets on emerging techs by eliminating single source bias, triangulating patterns, financials, and media signals so leaders see 12 to 24 months early when hype, reality, and innovations are out of sync. In our solution, we build a 12-agent intelligence system that works together like a small investor research team in a box. It sits on top of a pure graph rack Neo4j graph that only stores raw facts. No scores are hard coded, everything is calculated on demand. First, a discovery agent samples a balanced set of technologies from the graph using community detection. Then, four scoring agents running parallel, each focus on one of layer of truth: innovation, adoption, narrative, and risk. On top of that, a hype agent measures contradictions between those layers, and a phase agent maps each technology to the current hype cycle similar chart. Finally, a set of output agents run this into something C-level can actually use. Here you can see an example output from our multi-agentic system. Each dot on the hype cycle is a tech that agents have classified into one of the phases. And behind every dot, there's a local Neo4j graph you can zoom in to see patents, papers, and other docs, and other evidence that explain why it landed here. But we don't want this to be just a pretty chart. We want a scientific approach. So what happens if we run the full agentic pipeline again and again? Each run resamples a different community of related technologies in the graph. The agents recompute the scores and phases based on fresh evidence. Over multiple runs, we can see whether a technology stabilizes in the same phase or just around. This run is finishing. Let me explain what's different this time. In each iteration, we plug in the stability search tool, so the agents had access to much more news data. That's why see new technologies appear on the hype cycle. They cross the visibility threshold simply because we finally had enough external evidence about them. We repeat this process over and over, each time sample a different community in the graph. We don't just get one true view of a single cluster. We get multiple canopy views of the whole forest. Across runs, we can compare positions and move toward a consensus algorithm that more reliable maps where each technology truly sits. From progress, let me explain how we use ADE to power the data processing phase inside Canopy Intelligence. ADE extracts structured information from PDF of research papers, regulatory documents, and patents. These answer our graph with verified regulatory and financial signals, giving a solid foundation for the multi-agentic reasoning that comes next. In this demo, we still face some challenges. Our dataset was limited, which caused data sparsity and fewer graph connections that we hoped for. The hardest part was the entity resolution, matching company and technology names across many unstructured sources. With every new iteration, we get closer to building a scientific consensus-driven map of how technologies evolve. But this time, as we like to say,